The Permian is a geologic period and system which spans 47 million years from the end of the Carboniferous to the beginning of the Triassic period. It is the last and sixth period of the Paleozoic era. The Permian witnessed the diversification of the early amniotes. The world at that time was dominated by two continents known as Pangaea and Siberia, surrounded by the global ocean called Panthalassa. Sea levels in the Permian remained greatly low, and near-shore environments were reduced as almost all major land masses collected into a single continent, which is the Pangaea. This could have in part caused the widespread extinctions of marine species at the end of the period by severely reducing shallow coastal areas preferred by the marine organisms. During the Permian, all the Earth's major land masses were collected into a single supercontinent known as the Pangaea. Amphibians and reptiles dominated this era, while gymnosperms were the dominant plant. There are three general areas that are specifically noted for their extensive Permian deposits: the Ural Mountains, China, and the southwest of North America, including the Texas Red Beds. The Permian Basin in the U.S. states of Texas and New Mexico is so named because it has one of the thickest deposits of Permian rocks in the world. The climate in the Permian was quite varied. At the start of the Permian, the Earth was still in an ice age, which began in the Carboniferous. Glaciers receded around the mid-Permian period as the climate gradually warmed, drying the continent's interiors. The Permian period ended with the Permian Triassic extinction event, the largest mass extinction in Earth's history, in which nearly 96% of marine species and 70% of terrestrial species died. It would have taken well into the Triassic to recover from this catastrophe on land. Ecosystems took 30 million years to recover. There are some evidences that could lead on how this mass extinction happened. The first evidence is that magma, in the form of flood basalt, poured onto the Earth's surface in what is now called the Siberian Traps, for thousands of years, contributing to the environmental stress that led to the mass extinction. The reduced coastal habitat and highly increased aridity probably also contributed. Based on the amount of lava estimated to have been produced during this period, that may lead to release enough carbon dioxide from the eruptions to raise the world's temperature 5 degrees Celsius. There is also the flood basalt eruption theory. An increase in temperature of 5 degrees Celsius would not be enough to explain the death of 90% of life, but such warming could slowly raise the ocean temperatures until frozen methane reservoir below the ocean floor near the coastline to melt. Expelling enough methane into the atmosphere could raise the world's temperature an additional 5 degrees Celsius. Another evidence involves ocean venting of hydrogen sulfide gas. Portions of the deep ocean will periodically lose all of its dissolved oxygen, allowing bacteria that live without oxygen to flourish and produce hydrogen sulfide gas. If enough hydrogen sulfide accumulates in an anoxic zone, the gas can raise into the atmosphere. Models of such an event indicate that the gas would destroy the ozone in the upper atmosphere, allowing ultraviolet radiation to kill off species that had survived the toxic gas. Many scientists argue that the Permian Triassic extinction event was caused by a combination of some or all of the hypotheses that were mentioned. The formation of Pangaea decreased the number of coastal habitats and may have contributed to the extinction of many species.